Syngenta is a world-leading agricultural biotechnology company standing at number 1 in crop protection and number 3 in seed sales. They take research very seriously, having invested $1.3 billion in 2017 alone in research and development. Their next investment would be in a small group of students trained to be industrial engineers. The problem our group faced lied within the trialing stages of soybean varieties. At the start of the project, Syngenta had no quantifiable metrics to determine whether or not the genetic varieties of soybeans that continued to the subsequent stage was the best possible decision. These type 1 errors of poor-performing varieties could progress through the stages and eventually fail and be discarded. Syngenta's goal was to reduce type 1 errors earlier in the process in order to save resources. Using the dataset provided by Syngenta, the group filtered the level of success for locations and used machine learning to determine trends and significant features for each classification, all with the overall goal of decreasing these type 1 errors by 10%.
Before performing any analysis on a data set received, it is important to first validate the data that is being worked with. To do this, the group performed basic functions including minimum, maximum, and standard deviation to find any values that really stuck out from the rest. The next step was to see if the data provided information the way it was intended, which is to track varieties' performance throughout the years and stages. After trying various methods, the group landed on a final method that would be the most beneficial towards the goals of the project. This method looked at locations on a yearly basis of varieties that were in stages 3 or 4. Varieties in stage 5 were not observed because of issues found within the data provided by Syngenta. A percent progress calculation was computed based on how many varieties from stages 3 or 4 in a location in a given year would eventually make it to stage 6. This gave us a representation of how locations could influence the success of a variety. After tracking these percentages, a class value was assigned to a location depending on if it was in the upper 75% quantile, lower 25% quantile, or in between, which we called neutral. Using years 2010 through 2014, locations were given a class variable based on how they performed over the years. Once these class variables were assigned to a location, machine learning was utilized to identify attributes that could make a location most successful. Many different models were created ranging from random forest, regression analysis, and support vector machines.
This map not only shows each of the locations in our target domain, but it also categorizes the locations into one of the 3 classifications: lower 25, neutral, and upper 75. This alone will prove to be a very beneficial resource for breeders to use. It not only visualizes the data, which makes it easier to use and comprehend, but it allows them to use it year over year and see how a location's classification changes or stays the same. As my colleague Colton mentioned, machine learning proved to be an instrumental tool in going above and beyond our desired deliverable. Our machine learning fell into 2 categories: classification and regression. Classification works by analyzing the features or attributes of each location and determining how they impact the location's classification. Regression works by analyzing the same features, however, its output is a continuous attribute as opposed to a class. This was used in a model to predict the percent progressed, a key metric used for determining our classification for locations. Reflecting on the work done for this, the group is content with the results. This analysis and work done was majorly location-centric. Understanding that this is a problem that is dependent on both locations and varieties, the group is aware that there is more that can be done to improve the solution. Although this is outside the scope of the project, the group has a good understanding of how this could be further improved, and we have a report that can be continued by Syngenta to discover more information.
We were given the cost of planting a repetition for a single variety and wanted to find the cost of planting varieties that were terminated for poor performance. The reason for this approach was because it is sensible that in stage 3, Syngenta would want to terminate all of the low-performing varieties to minimize the cost of material handling and planting of such varieties. So by using the latest data provided, we looked at the number of varieties in stages 3, 4, and 5 in year 2013 and identified approximately 200,000 varieties. We then looked at stages 4, 5, and 6 of the next year, 2014, and identified approximately 150,000 varieties. That presented a difference of approximately 50,000 varieties, which symbolizes the number of type 1 errors. We multiplied this by the cost of planting and determined the cost of type 1 errors to be approximately $400,000. Groups 10 deliverables, including the color-coded map, final report, and all of our written code, will decrease the amount of type 1 errors by at least 10%, which saves Syngenta approximately $40,000 a year.